In this video, we're going to continue our discussion on the definite integral with a few examples. So, to get right into it, let's say we have a function f at x equals 9x squared plus 2x minus 7, and we're asked to find the integral of f at x dx, right? So what would that be? And sorry, also on from the interval from 1 to 2, okay, because that's what makes it a definite integral. It's the interval here. And remember that the definite integral is the area underneath a curve. So if this curve represented f at x, okay, let's say this curve represented this polynomial here, which of course it doesn't, but let's say it did, then the definite integral, this would be the area underneath this curve here, which is going to give us a number and not just a function. So let's go ahead and compute that. So the integral of 9, we'll say from 1 to 2, of 9x squared plus 2x minus 7 is equal to the integral from 1 to 2 of a 9x squared dx, I should put a dx here, dx, plus the integral of 2x dx minus the integral of 7 dx. I'm also going to put our intervals here, 1 to 2 and 1 to 2. Now, one of the nice properties about the integral is that we can actually take out the coefficient. We can take the coefficient out of the expression here. So we can take this 9, because it's a constant, okay, we can take any constant out, 1, 2, x squared dx, plus, we take this 2 out of the integrand, okay, so we'll take the 2 out of the integrand, and 1 to 2 dx, and we can even take this 7 out of the integrand as well. So that would have 7 from 1 to 2, and that just leaves a 1 here, okay, dx. And from this point on, we can go ahead and solve our integral. So this integral right here would be the same as 9 times x cubed over 3 from the interval 1 to 2 plus 2 times x squared over 2 from the integral 1 to 2, and then minus 7 times, okay, and then this just increases to x from 1 to 2. And then we can go ahead and further simplify this. So this would be the same as 3x cubed from 1 to 2 plus these 2's cancel out, x squared from 1 to 2 minus 7x from the intervals 1 to 2. And then we can go ahead and write, we can go ahead and substitute 1 and 2 in to our x values. So this would be 3 to the power of 2 squared minus 3 times 1 squared plus, okay, plus 2 squared minus 1 squared, then minus, okay, 7 times 2 minus 7 times 1. And so we can go ahead and simplify that. So that would give us, I'm just going to scroll down a little bit here. That will give us, so 2 to the power of 2 is 4. 4 times 3 is, or sorry, this should be cubed, my bad. This is a cubed, not a squared. Okay, so 2 cubed is 8, times 3 is 24. And then moving on over here, minus 3 plus 2 squared is 4. 1 squared is just 1, so 4 minus 1. And then 7 times 2 is 14. And then 7 times 1 is just 7. And simplifying even further, we have 21 plus 3 minus 7. And then when we add all those together, so add 21 to 3 and then subtract 7, we are left with 17. Okay, so 17. So what this means again is 17 would be the area underneath this curve right here from the interval 1 to 2. Okay, so that means that if this curve right here was f at x, okay, and this was, and a was 1 and 2 was and b was 2, then this area right here is 17. Right. Let's do one more example. Right, one more example. So let's say that the speed of a car on a racetrack is represented by the equation v at t is equal to 4t plus 3. Okay, and this is in meters per second. And then we are asked to find, get a different color here, how much distance, okay, find how much distance the car has covered from time 1 second to 3 seconds. Okay, so if you start the time at 1 second after the car has started and then stop the timer at 3 seconds, how much distance has the car covered in that time period? So find the distance, okay, covered from 1 second to 3 seconds. Okay, so we know that the distance, okay, the distance of an object in motion is equal to the integral of its speed. Okay, so we would write, let's get a different color here. So the distance d at t is equal to the integral of, okay, the integral of v at t dt. So what we can do here is we can plug in our function here. All right. Now, since they want it to be from, they want to get the distance covered from 1 second to 3 seconds, we can put that in as our intervals. So we'd put in 1 second here and 3 up here. All right. That's what this question is asking here. So we'd go ahead and substitute our function in. So 4t plus 3 dt. And then we would just go ahead and solve that. So that's also equal to the integral from 1 to 3, 4t dt plus the integral 1 to 3 times 3 dt. We would further solve that. 1 to 3, or let me put it this way. We can take out the coefficient, okay, 4 t dt plus 3 1 to 3 dt. And then we'll go ahead and solve this integral. So that would give us 4 times t to the power of 2 divided by 2 from the interval 1 to 3 plus 3 times, remember there's like an imaginary 1 here, so this 1 will go up to an x, right? 3x, or sorry, 3t I should say, not x. Old habits. From 1 to 3. And now we can go ahead and solve. So remember, this simplifies to a just 2t squared 1 to 3 plus 3t 1 to 3. Scroll down a little bit here. We can go ahead and substitute our intervals into our function. So for this piece here, 2 times 3 squared minus 2 times 1 squared plus 3 times 3, okay, we're going to substitute 3 in for t, minus 3 times 1. And then from this point on, we'll go ahead and simplify this even further. We got 2 times 9 minus 2, or 2 times 1 plus 9 minus 3. Solving this even, or shortening this even more, we are given, so this would be 16, so yeah, 2 times 9, 18 minus 2, that's 16, plus 9 minus 3, which is 6, and in the end that will give us 22. So what that means is the car would have covered 22 meters in that time. So that is, these are some more examples of definite integrals, and in the next video we're going to talk about a cool trick that you can use for solving slightly more complicated problems.